Sounds good? Okay. Well, hello again. My name's Mike Baumforth. I'm back to lecture today on weld inspection and a little bit about certified welding inspectors. They're the guys who typically are called upon to do weld inspection. And so, as we go through this, if anybody has any questions, feel free to ask. Before we get into the details of inspection too much, I wanted to talk a little bit about quality. So what is quality? When you hear the word quality, various things might come to your mind. But in terms of manufactured products, and I don't know if Professor Eagers covered this or not, but in order for something to have quality, it has to be measurable. It has to have a measurable conformance to a specification. Oh, and I actually have some handouts for you today. So if you want to pass those around, you can follow along. So to establish product quality, there has to be something that's measurable. In order for something to be measurable and to determine whether it meets that quality, there has to be a specification or a code. There has to be something that states what the requirements are. And so when we talk about quality of welded materials, we talk about welding codes and welding specifications. In order to be able to be the quality person or the certified inspector or wherever we fit in the process, we need to be able to read and understand and apply the provisions of those governing documents, of those codes and standards that are often cited in the contract or the purchase order or the job specification. Another thing that comes up a lot in welding quality for specifically is the difference between a discontinuity and a defect. You might say, well, those sound like the same thing. That's what most people think. But in terms of welding quality, a discontinuity is anything that interrupts the general flow or the uniformity of an object. A defect is a discontinuity, but it doesn't meet the specifications, or it doesn't meet the codes. It doesn't meet the provisions of those codes. And so, for example, later on we're going to talk about some of the specific discontinuities and defects that we might find in welds. But one of them is porosity. If you have a single small pore in a weld, it's a discontinuity, but generally, if it's small enough, it's not a defect. It doesn't violate the code because the code will allow you to have a certain number of pores in a certain length of weld and a certain size. And so when it becomes a defect is when it violates those provisions of the code, those certain numbers and those certain sizes. So just wanted to say a few words about the different documents that would be used. A code is a body of laws that's arranged systematically for easy reference and use. Easy being put in quotation marks because sometimes the codes are somewhat complicated. But because a code has legal status, it's by definition mandatory. And so an example of a code is the structural welding code that you've probably heard of in this class. It gives the legal rules. It uses the word shall when something is mandatory. It also uses the word should when something is just recommended. But anytime there's something in the code and it says you shall do this, then if your contract specifications say that you need to follow AWSD 1.1 and it says you shall do this, then that's mandatory. There's no debating that. The second document type is a specification, and a specification gives a detailed description of the parts of a whole or a statement of particulars. It talks about size and performance and quality. It describes all of the pertinent technical information for a material or a product or a system or a service. And it talks about how those requirements should be met. And so one of the types of specifications that we deal with is a weld procedure specification. It tells you how you should make your weld. It tells you how to meet the code requirements, but it doesn't actually have all of the code written into that specification. And so it's one level down from the code. The next level is a recommended practice. It's a non-mandatory description of generally accepted industrial methods or techniques. The American Welding Society puts out a lot of recommended practices for gas tungsten arc welding or for shielded metal arc welding. It's industry knowledge that gives you a great idea about how to go about doing these things. It's just not a code. It's just not mandatory. And then there's even one level down as a guide, and that just provides information on proven methods to accomplish certain tasks. And so, for example, there's a guide for the visual examination of welds. It says if you're going to look at welds, you're going to examine them, these are the kinds of things you should be looking at. So who does these inspections? Well, there's, like I said earlier, there's a lot of people involved in weld quality. You have your quality assurance personnel at the place where you might be working. You have quality control personnel. But the person that I wanted to spend the most time on is the person who's actually out there doing the inspections, and that's a certified welding inspector. If anything of significance needs to be inspected, they require a certified welding inspector. They can't just have, you know, Joe Blow on the shop looking things over, although that does happen sometimes. So what does the certified welding inspector do? He performs inspections. He verifies that the work that's being inspected and the records that were maintained conform to the requirements of the applicable standards. The big thing that he does is he compares what's actually there with what's required to be there. So he compares actual with required product specifications. So as things are going along, he's looking, he knows what the requirements are, he's checking to make sure that what's actually happening is meeting the requirements. When things are all done, he'll get out his weld gauges, he'll get out his magnifying glass or his flashlight, and he'll look things over and he'll make sure that what's actually there is consistent with what was required in the specifications. And the big thing there is appearance alone is rarely the determination of product quality. So it's more than just looking. It's having an understanding of the whole process, having an understanding of what went into making that welded product, and being there as that process goes along. So what's required to be a CWI? You can't just decide that you're going to be the CWI for your company. There are some education and experience requirements. All of this stuff is spelled out in great detail on the AWS website, aws.org. But for any of you here, because anyone who has an associate's degree or higher, you're still required to have 3 years of on-the-job experience. They've got other levels. If you're only a high school graduate, you have to have 5 years experience. If you made it through 8th grade, you have to have 9 years experience. If you made it through less than 8th grade, you have to have 12 years experience to become before you can apply to become a CWI. once you fill out the paperwork and you put in your application, you send AWS your money, then there's three 2-hour sections of basically it's an all-day exam that you have to take. And that's divided into three sections. The first is a fundamentals section, which basically talks a lot about the different welding processes, the non-destructive techniques for testing those welds. The next section is a practical application section, which is using techniques that we'll talk about later. For visual inspection, you actually have some little plastic molds of welds, and they give you some tools, and they ask you a bunch of questions about how you can practically do the weld inspection. And then the third section is the open codebook section, and they ask you a bunch of questions on your choice of codes. Most people do either the D1.1 code or the API 1104 code, which is a code that's used for the welding of petroleum pipelines. When I first went to do this, I thought, well, this is really thin, I should do the API code. But it actually turns out to be easier to do the D1.1 code, because for one thing, the D1.1 code has an index, whereas this one doesn't. And this one just has a lot more information. It's actually easier to find things, as opposed to this one is just a bunch of pages, and you basically have to, unless you really know this code, you have to really look through to find everything. Another thing that, yeah. Go ahead.
To what extent are products actually verified? For example, you have like a manufacturing line, you have thousands of products. How many of these are actually sampled by the welding inspector? It's not when you take like a product and be like, these are okay, or it can be every single product that comes off the line.
Well, so he's asking what extent are things inspected? Is it every single product? Is it part of the products? And that's a question that really depends on the product. It depends on the people who designed it. It depends on the code that it's being inspected to. But some of the codes will actually provide provisions for that. But for example, I used to work for a national lab where we made nuclear weapon components, and we inspected every single one of those. If you're making car parts and you're making thousands of them, I'm sure they're not inspecting every single one of those, but they've worked out some kind of a statistical system where they are comfortable that if they randomly select and inspect that they're meeting their requirements. Just by way of information, there are other codes that you can receive a CWI by taking the test for. There's D1.2, which is the aluminum welding code. There's D1.5, which is a bridge welding code. D15.1 is the railroad welding code. You can take a test on the ASME, boiler and pressure welding codes. So, if you come from one of those industries and you know those codes, it's a great idea. If you're just looking for a general CWI, I would actually recommend the D1.1 code. And then the last requirement to be a CWI is you have to go and have a vision test. They have to check and make sure that you can see, because a lot of what you're doing is looking at things when you're inspecting. So those are the formal requirements. These are some of the inherent requirements, I guess you would say. There's actually a nice little sheet that I found in one of my books that a CWI brings cash to the job. And what that stands for is knowledge, attitude, skills, and habits. So he's got his 4-drawer file cabinet up there with all of these various attributes that a good inspector would have. And we'll talk about a few of those. It's important to have a professional attitude. You're dealing with a wide variety of people. You're dealing with the actual people who are making the welds, the welders. You're dealing with supervisors. You're dealing with schedulers, and you're dealing with a lot of different people trying to ensure that the quality is high. And depending on the interest of that person that you're dealing with, they may or may not feel as strongly about it. And so it's important that you have a professional attitude and that you work well with these people. It's important that you have good physical conditions. Sometimes you're climbing around a crane or a bridge or a pressure vessel. Sometimes you're down on your knees. Sometimes you're climbing over things. So it's important that you're in fairly good physical condition. It's important that you're ethical. If you're not willing to stand up for what you know is right, if you're not willing to make sure that those codes are followed, then you're not going to be a very good welding inspector. You need to be a good communicator. You need to be able to, like I said earlier, you need to be able to communicate with those various people and explain things so that they can understand them. If you find a defect in the weld that needs to be repaired, you need to be able to communicate that to the welders so that they know what it is that they need to repair. And then you just need to have a good general knowledge of welding and welding metallurgy and welding in general. And we'll talk about a few of those. We'll talk about welding positions, the joint types that you might come across, the welding symbols that you might come across, and the electrode identification systems. And the reason that those are important is before you ever start inspecting welds, when you go to a job, often you're going to go and look at their documentation. And so you need to be able to look at their weld procedures, and you need to be able to look at the things that they've got describing what they're doing. And if they've got weld symbols on there, or it's talking about a certain weld joint, you need to understand what that is. So first off, with welding positions, I'll show you some sketches of some of these. But first off, you have a couple of different kinds of welds that can be made. One is a fillet weld, which is a weld between two 90-degree pieces of structure or pieces of metal, where if you've got a piece of metal here and a piece of metal here, you're going to put a weld right there. That's a fillet weld. The second type of weld is a groove weld, where if you've got, looking at a cross section, you've got a couple of pieces of metal that you want to weld together, and you're going to put a weld in here. That's a groove weld because you're filling up the groove. And so that can be done in a variety of positions. It can be done in the flat position. This is the flat position. If you're welding from up here, it's flat. You're welding straight down. That's the easiest, and so that's designated as a 1. And so if you have a 1F fillet weld, then that would actually look something like this. You're welding here. That's 1F. 2F is horizontal. So if you just tilted this a little bit, then that's a 2F fillet weld. Or if you put this up on its side and you're welding along like that, that's a 2G. So the other positions that you could have are vertical, overhead, and then when you're welding pipe, you can actually rotate that pipe. So if you're welding on a pipe here and you're rotating the pipe and you're just welding from up here, then it's actually in the flat position. You're just rotating the pipe underneath. And so you might have a 1GR, which means it's rotated. You might also have a fixed pipe, and that's what 5 is, 5 and 6. If it's in the horizontal position and it's fixed, it's a 5. If it's in a 45-degree position and it's fixed, then it's a 6. And if you have the R with the 6, then that means it's restricted. And I'll just show you a picture of that rather than try to draw it. So try and blow these up a little bit. So this first set right here, like I mentioned, if you had the plates are horizontal, you're welding from the top. That's a 1G groove weld there. 2G, your weld is actually horizontal. Your plates are vertical. The 3 position, which I mentioned was vertical, is like this. Your plates are vertical and your weld is vertical. And then overhead is when it's upside down and you're actually, like it says, you're welding overhead. This is the same type of thing for fillet welds rather than groove welds. This is what I drew right here. This is a 1F fillet weld. This is a horizontal fillet weld, or a 2F. This is vertical. You're welding up or down. That's something that might be called out in your weld procedure, is whether you're making a vertical weld in the up position or down position. And then overhead, once again, is up above. And just to show you a couple on the pipe. So this right here is a 1G because the pipe's being rotated, as opposed to this down here actually looks the same, but it's a 5G because the pipe is fixed rather than being rotated. This would be 2G. The pipe is vertical and the weld would be horizontal. I talked about the restricted on the 6 position. This would be a regular 6G pipe weld. This would be a 6GR because you've got something in there that's restricting your access. You may have a flange or something around that pipe. The next topic I wanted to cover then was welding joint types. There's five main joint types that we would make in welds: butt, corner, T, lap, and edge. And I'll show you pictures of those in just a minute. There's some rules that go along with those. You might hear of a single bevel butt joint, for example. And what that means is, where I drew this here, this would have actually been a double bevel because both of the plates were beveled. A single bevel just means that only one of the plates is beveled. So double means both, or welded from both sides. Bevel refers to one of the members, so you can single bevel that or double bevel it. Actually, I think I said this wrong. This would be a single bevel weld because it would all be welded from this side. You can also have a double bevel, and what that means is that your piece looks like this because it's then welded from both sides. Another type of edge preparation that we sometimes have is a J groove, which looks kind of like a J. So you can have a single J, or you can have a double J, which becomes a U groove. So here's an illustration of the various the various types of joints. So a butt joint, you're butting two things together just like it sounds. A corner joint is just like it sounds as well. You're making a weld on a corner of two plates or two components. A T-joint is just like it sounds as well. The parts are actually making a T. A lap joint, the parts are overlapping. You would weld that with a couple of fillet welds or at least one fillet weld. And then an edge joint is where you've got two pieces on edge and you're welding along the edge of those. Question?
Is it still considered a butt joint if you have like two very shallow angle bevels that kind of overlap? I'm not sure if that's even necessarily a good weld, but
Yeah, I mean that would be it would be considered a butt joint with like a scarfed edge preparation or something. I think is what the terminology would be.
The code defines geometric. The book's not that thick for a reason.
Okay. The next thing is an inspector needs to understand what the welding symbols mean. And so there's various parts of a welding symbol. I'm going to put some pictures up here and we'll talk about those parts. This is a welding symbol, or this is kind of a map for making a welding symbol. The reference line is just this line right here. That's kind of where the information is centered. It's put upon that line. And if you'll notice right down here, it says that information would remain the same whether the arrow was on the arrow and the tail were switched sides. That reference information would all remain right there. The arrow is required, and the arrow points to where the weld is supposed to go. And then there's information on the reference line. Above the reference line is called the other side. So if I was making a weld right here, I wanted to fill this up with weld metal, and I put my weld symbol down here, and I wanted to put my information for that weld, I would put it on top of the line because that's the other side, so it's being made on the other side. If I wanted to put a back weld down here, I'd put the information down here. That's the arrow side. Question?
Is this stuff that you use in a drawing or at all?
Excuse me?
Is this a typical notation that you use in a drawing?
Yeah, I mean this is the stuff that goes on the drawings, so that.
So where do you find this?
Uh,
They specify this. And what kind of book? General Measuring Forms. Some of them do like, they deal with welding. Yeah. AWS has a whole book on symbols. And anyone who's doing weld detailing knows these, and most of your CAD programs would have these in the program. You send it out to a shop if you want just to keep it on. Right? How would you communicate to just any ordinary machine shop? Just two minutes.
well, and you want to have it welded, I mean if they know welding at all, they'll understand the weld symbols.
Yeah, if it was critical and the shop didn't know what this drawing meant, I wouldn't use the shop. Okay? Things that are just fly by night. Okay, this is standard. It's been around for 80 years. Okay.
But if you are looking for a reference for making your drawings, like Tom said, AWS has a whole handbook on welding symbols, or you can get them out of the code. You can get them out of technical handbooks. You can get them in a lot of different places. So the next thing on the list is the tail. In the tail, we place you place specifics on the process. There's not always something in the tail. In fact, sometimes they leave the tail off if there's no information that needs to be put in there. But if you want to specify the process that you weld with or something like that, you put it in the tail. The basic weld symbol is not shown here. These are actually the basic weld symbols. And so one thing to point out, there's a difference between a weld symbol and a welding symbol. The weld symbol are these symbols here, which are a part of the welding symbol. The welding symbol is the whole symbol. These are the type of weld that goes in that joint. And so if you're making a V groove joint, you put the V on there. Another, a very common one is this fillet symbol. If you're putting a fillet in there, you put the little triangle. So there's a variety of different types of welds that can go in these different joints that we talked about. And so these are the symbols that go above or below the arrow line. And those are all, they're all in the handbooks and stuff as well. A lot of times you need to put the size of your weld. You put that here or here. If you're making a 1/4 inch weld, that needs to be on your weld symbol. There's all kinds of other supplementary and finish symbols that can be added to a weld symbol. Most weld symbols aren't going to have all of this on there because people don't deem it all important. But if the finish of your weld, if it has to be ground flush or something like that, then you've got to put that up here. You've got to put that in your weld symbol. Next, I wanted to just talk a little bit about electrode identification systems. And this is just part of that general knowledge, understanding when a weld procedure says you've got to weld with shielded metal arc welding, which is stick welding, and you've got to use E7018 electrodes, you need to understand what that means. And so shielded metal arc welding, like I said, is stick welding, and those electrodes always are going to start with an E, and then the following two X's, if they're 70 or 60, or they can't even be 3, they can be 110 or something like that. That's the tensile strength that's required of that filler material. The third X is a position, so a 7018 can only be used in well, it can actually be used in all positions. One refers to all positions in these systems. And then 8 in a 7018 actually refers to the fact that it's a low hydrogen electrode. So the last digit is a coating or operating characteristics identifier. In gas metal arc welding, which is MIG welding, you might know more commonly, that's always going to start with ER. The R stands for rod. And then you've got a couple of digits that identify your strength again. So you might have an ER70, and then you might have an S3 or something, which indicates your silicon level. It indicates the chemistry of your filler material. For flux cord arc welding, do they know the weld processes?
Not from this course. In other modules, I go through it, but they don't know from this course.
Flux cord arc welding is basically a little tube of material that's got flux on the inside of it, but it's welded much like MIG welding. It's a wire-fed system. So there you've got an electrode. The E stands for electrode. Then you've got a strength digit and a position digit. The T stands for tubular. It's a tubular electrode. And then you've got a chemistry digit as well. And that submerged arc is the last one I've got up there. Submerged arc actually has specification for the flux and the electrode. I don't know if you're familiar with submerged arc welding, but you're actually welding through a big blanket of flux. And so they specify the flux as well. So that's why you've got both F and E. You've got a strength and chemistry requirement on the flux, and then you've got chemistry and manganese contents on the electrodes as well. And these are all things that are spelled out in various codes and handbooks and stuff as well. Not going to spend a lot of time on this. These are just the various sections in the AWSD 1.1 code. It's divided into 8 sections. Unless you're doing something specific like stud welding or fixing existing structures, you're mostly going to use the first 6 sections. Really, unless you're involved in design, you may even only just use just a few of the sections. But basically, the design, the second section, the part hasn't been built yet. These are the design things that you need to consider. In AWSD 1.1, this is a little bit different than a lot of codes. They actually have pre-qualified processes. So if you've got processes and parameters that have been proven over time, you can just look in there, you can write out your weld procedure, and you don't have to actually do the qualification testing because it comes out of the code. It's been proven over time. If you're welding something where you don't have the ability to do those pre-qualified procedures, then Section 4 tells you everything you need to know to do that qualification. And then fabrication gives you the rules for how to make things, how to weld things. And then inspection has the requirements and the acceptance criteria that we talked about. It gives you all of everything you wanted to know about porosity and cracks and lack of fusion and whether or not it's acceptable and what the parameters would be. I think Tom has talked to you a little bit about the qualification of the procedures. I just wanted to throw this up for a few minutes. The weld procedure specification is the document that the welder would use